Hello everyone and welcome to the first class of this week. And today we are going to talk about the estimation of the sex of the individuals. We are going to start this week by establishing the difference between biological sex and gender. According to the World Health Organization, biological sex refers to the different biological and physiological characteristics of males and females, such as reproductive organs, chromosomes, hormones, etc. And gender refers to the social constructed characteristics of women and men, such as norms, roles, and relationship of and between groups of women and men. It varies from society to society and can be changed. So in Human Osteology, we are estimating the biological sex and not the gender. It is possible to estimate the sex because of the sexual dimorphism. In humans, this is complex, with behavioral, physical, and anatomical dimensions. Anatomical differences are more pronounced in some soft tissue areas, but much more limited in the skeleton. On the skeleton, the sexual dimorphism is mainly marked by the reproduction, different genetic influences in the development of bones and their proportions, and the differences in the amount and proportion of muscle mass. The men tend to have bigger bones and more marked muscle insertions. The differences in the skeleton of a female and male human starts in the fetus, but are almost impossible to see. During childhood and adolescence, the differences begin to accentuate, but they are still soft. At 18 to 20 years, they are well marked. Taking this into account, the sexual estimation of human skeletons is more accurate after the individual reaches maturity. In general, the skeletons of female individuals are more gracile and smaller. On the other hand, the male skeleton is usually heavier and bigger. However, it is always important to keep in mind the morphological variation. Each individual may have mixed characteristics that can be due to the biology of the person or because of the interaction with the environment. This can cause mixed characteristics or even a male skeleton with characteristics associated with a female skeleton, and the other way around. For example, a woman that makes a lot of physical effort may have more muscle than a man that doesn't exercise. The sexual estimation can't be done with every bone in the skeleton. The more dimorphic bone is the cocci, and this is related to the ability that the females have to give birth. And because of this zone must be adapted. The long bones are the second more dimorphic, and lastly the skull. To analyze these bones, there are morphological and metric methods. The morphological methods are applied to the cocci and the skull, and they are based in the macroscopic observation of certain parts of these bones. These methods are influenced by the experience of the observer, and two people can give different values to different characteristics. The metric methods are applied to the long bones and are based on measures in certain parts of the bones. And unlike the morphological methods, these aren't influenced by the experience of the observer. We are going to start by seeing the morphological methods applied to the cocci and the skull. There are several methods to estimate the sex, but the one that I'm going to present you is the method by Fehrenbach and collaborators from 1980. This method is used both to the pelvis and the skull. This is a long method because there are a lot of characters, and you don't have to know them all. I will tell you the ones that I think are more important to keep in mind. So, in this image here is part of a table from the method, and you can see that it has the characters to each bone, and each character has a different weight on the final decision. Each character can be classified into 5 categories: hyperfeminine, feminine, neutral, masculine, and hypermasculine. And each of these categories has a description. And in the end, we make an equation with each character, and it gives us the final result. The first character is the Prioricular Sulcus. The sulcus is near the auricular surface, as you can see here in this image, in this zone. And when this sulcus is present and well demarked, it means that it is a feminine character. And when it is absent, it is a masculine character. In this image A, you can easily see that sulcus, and then in image B, you can see a sulcus. So, in this case, the image A would have a score of -2, and image B a score of +2. And this is an important character to know because it is easy to identify. Another important character is the greater sciatic notch, and it's by seeing its shape. The sciatic notch is here in this zone that I'm pointing, and when it's very wide and with a U shape, it is a feminine character. On the other hand, when it is narrow and with a V shape, it's a masculine character. So, in these images, you can see part of the cocci from a female and a male individual. And in here, you can see that the greater sciatic notch is very wide and has like a U shape, so it's a feminine cocci. And in this image, you can see that the greater sciatic notch is very narrow, and this is a male cocci. The pubic angle is also an important character. In males, this angle is more acute, and in females, more obtuse. In this image, you can see very well that in image A, here in this zone, this angle is very acute. And then, in image B, this angle is obtuse. So here we are looking at a masculine pelvis, and here we are looking at a feminine pelvis. The composed arch only has two hypotheses, or it is double curved or single curved. And you can see the composed arch is here in this zone of the cocci. And although it only has two options, it is a difficult character to analyze. To see what type of composed arch the cocci has, we have to make a line near the auricular surface, which is here, and then come down to see if the bone forms one or two curves. And this is easier when you have the bone in your hands and you can feel it. But in this image here, it is a feminine, and in here is a masculine. And you can see that here it makes one and two curves, and in the masculine it only makes one curve. So in this character, we are not looking into a specific part of the bone, but the general form of the cocci. The cocci in females is more low and broad, and in males is more high and narrow. And in these images, you can see the difference between a male and a female cocci. In this figure, in figure A, you see that the bone is higher and it is narrow, unlike in figure 2, which the bone is lower and broad. So this is a female cocci, and here this is a male cocci. The Actuator Foramen is another character that can be analyzed. This is not easy to see, and a lot of the times we have an unclassifiable form. In females, this foramen has a triangular shape with sharp rims. You can only classify the rims if you have the bone in hand to feel it. In the case of males, this foramen is oval with round rims. As you can see here in these images, the form of this foramen can be approximate to one of these forms. So now we are going to look at the Alia Crest, which is here in this part of the ilium, and the iliac fossa, which is this zone here of the cocci. It's difficult to see the Alia Crest without the bone, but in these two images here, you can see the difference between a feminine and a masculine Alia Crest. You see this zone here of the Alia Crest of a female, and this part is more flat. And then if you look at the Alia Crest of a male individual, it has more of an S shape. And about the iliac fossa, we are following the same logic that we use looking to the cocci as a whole. The feminine iliac fossa is low and broad, as you can see in here, and then the masculine is high and narrow. And finally, we have to look in a superior view at the pelvis in articulation. The pelvis major is this area of the bone that I'm doing, and then the pelvis minor is this zone of the bone. In both, the feminine pelvis is broader, and in the case of the pelvis minor is oval. On the other hand, the pelvis major and minor of males are narrow, and the minor has almost the shape of a heart. In this image, you can see clearly the oval shape here in a feminine pelvis, and you can see here, you can see the heart shape of the pelvis minor of a male pelvis. And this character is an important one to analyze. So now I'm going to give you an example of how to use this method with the characters that we can see here in this with this bone, in this position. So starting with the Sulcus Spuricularis, you can see that it is absent, so it gives us a score of +2. Then we have the greater sciatic notch, and it has a V shape, but it is not very narrow, so it gives us a score of +1. Then we have the composed arch, and if you look at here, you only have one curve, so it gives us a score of +2. Then looking to the bone as a whole, we see that it is high and narrow, giving also a score of +2. And finally, the iliac fossa, this zone here and here, it is also very high and narrow, as well as the Cocci, giving also a score of +2. So, using the equation, it gives us a value of 1.8. When this value is superior to 0, it means that it is a masculine individual, and when the value is under 0, it's feminine. If the result is 0, the sex is undetermined. So in this case, this Cocci probably belongs to a masculine individual. Now that we've finished the sex estimation with the pelvis, we are going to estimate the sex using the skull. The first character is the glabella, and as I told you in week 2, the glabella is an important point to estimate the sex. The glabella is smooth in females and prominent in males. In this image, you can see that it is this zone here of the skulls that this arrow is pointing, and that this skull is from a male, and you can see that the glabella here is prominent, and when you look at this skull, that it is a female, you see that this zone here is smooth. The zygomatic process is another character that can give us information about the sex. And the zygomatic process is this part here of the skull. In females, it is very thin, and in males, very thick. And in these images, you can see the difference between the sexes. In the male, you can see that this zone is thick, and then if you look at here at this female skull, you can see that this zone is thin. Now the Supraciliary Arches. They are marked or very marked in the males and smooth or slightly delimited in the females. This skull is from a male and this skull is from a female. And you can see here this zone of the skull, these are the Superciliary Arches, and you can see that they are marked in this skull. And then when you look at this skull here, that is from a female individual, you see that they are only slightly marked. And this is also an important character to know. The frontal inclination is usually easy to see. You have to look at the skull in a lateral view, as these images are, and you have to look at the frontal bone here in this zone and see if it has a vertical position or more of an inclined position. If it is a vertical or almost vertical, you are seeing a feminine character. As you can see here with the skull, in this zone, this is almost vertical. And if it is inclined, it is a masculine character, as you can see here in the skull of a male individual. The orbital form, I think that it is a character that it is a little hard to apply, because most of the times the form of the orbits seem to have a transitory form. In my opinion, this character implies a little of experience. But I think with these examples you might see the difference. So in females, the orbits tend to have a more round shape and have sharp borders. Unfortunately, to evaluate the borders, you need to have the bones in hand, so you can classify this part. In the males, the orbits are usually quadrangular. So this skull here, that it is a male, this zone here that this arrow is pointing, you can see almost a 90-degree angle, so it gives more a quadrangular form. But then, when you look at the other orbit, it has more of a transitory form. In this skull here, that it is a female, if you look at this orbit, especially this zone that I'm pointing, you can see that they have more a round form. But then again, this orbit has more of a transitory form. The nuchal crest and the inion are important and a lot of the times are easy to analyze. To see both of these characters well, we should be looking at the skull in a posterior view, but I couldn't find any good skulls in this view. So the inion is this point that is in here in the skull, and the nuchal relief is the zone near the inion. Looking at these skulls, you can see that the inion, you can see clearly this point here in the skull, that it is a male skull. And then, if you look at the same zone here in the skull, you can see this point. So, when the inion is not marked, it is a female character, and then when the inion is marked, it is a male character. The nuchal relief is also smooth. If you look at this zone here, is smooth in the females, and then it is more marked here in the male skull. Lastly, we are going to look at two characters of the mandible. First, we have to see the overall aspect of the mandible. If the mandible is gracile, it is a feminine character, and if it is robust, it is a masculine character. In these skulls, again, this is a male skull and this is a feminine skull, you can see that the size of this mandible is bigger than this one. So this mandible is robust, so it is a male character, and this mandible is gracile, so it is a feminine character. And the final character is the mentum, and the mentum is this zone here of the mandible. In general, the masculine mentum is prominent and the feminine mentum is small. And it's possible to see in these skulls here, this part, the mentum, is marked, and this is a male skull. And if you look at this part of the mandible in the female skull, this one is slightly marked. And now I'm going to give you an example of how to use this method with this skull. First, we have the glabella, and the glabella here is smooth, so it gives us a value of -2. Then the mastoid process is very small, being also -2. As you can see here, the zygomatic process is very thin, giving also a value of -2. And then we are looking at the Supraciliary Arches, that they are only slightly demarked, so it gives us only a value of -1. The Frontal Inclination is also -1 because it is almost vertical. The Orbital Form is round with a value of -2. The nuchal relief and the inion are smooth, so they both of them are -2. Then the mandible, and the mandible is gracile with a value of -1, and the mentum is small with also a value of -1. So, using the equation, it gives us a final result of -1.5, which is under 1, so the sexual estimation points to a female skull. So, lastly in this class, I will present you a metric method, in this case by Westerline 2000. This method was developed with Portuguese osteological collections. With these metric methods, it's extremely important to choose the ones that were developed with a similar collection that you are studying. For example, if it is an American collection, you should use a method that were developed with an American population and not, for example, an European population. So the metric methods have a split point. Any value, in this case the measures, above the split point means that the individual is masculine, and any value below the split point means that the individual is feminine. And if the value is equal to the split point, the sex is indeterminate. So in the method by Osterline 2000, there are several measures in different bones that you can make, but I will present you only the ones that have a success rate above 80%. And these measures are the vertical diameter of the head of the femur, as you can see here in image 1, then the vertical diameter of the head of the humerus, as you can see here in figure 2, and then the maximum length of the radio, as you can see here in figure 3. For example, if the measure of the head of the femur was 47.60 millimeters, this was a masculine femur because this value was above the split point. In the case of the humerus, if the measure was 39.55 millimeters, it was a feminine humerus because it's below the split point. And finally, if the length of the radio was 222.36 millimeters, it was from indeterminate sex because the measure was the same as the split point. In the next class, we are going to learn how to estimate the age at death in adults. If you have any questions, please let me know, and I will see you next week.